All right, class. So we have our lesson in probability today, and our activity is called Flip Cup. Now, this is a game in which you are trying to flip the cup. So you take your finger, you place the cup on the edge of a desk or a table or whatever surface, as long as you are able to use your finger to flip that part of the cup that is hanging over the edge. Now, you could set it up right side up or upside down, and the goal would be to flip it and get it to land either right side up or upside down. So our activity involves probability because we're thinking about the probability of landing it right side up, upside down, or on its side. So what does this do for us? Well, it helps us understand the difference between theoretical and experimental probability. So we can use our findings to help us make predictions about future outcomes. So remember, theoretical probability is what we expect to happen. That's what we calculate, and we say if we flip a coin, well, 50% of the time it should land on heads, 50% of the time it should land on tails, right? However, when we actually flip the coin, when we experiment, that is when we find out what our experimental probability is. So in this case, flip cup, it's kind of hard to know. The cup is in an irregular shape, and we may flip with different force, and we have, you could land it right side up, upside down, or on its side. So our theoretical probability would be a little difficult to calculate. So that's why in this case, we would want to experiment. So what do we think is going to happen? Before flipping the cup, think about the possible outcomes. Right side up, upside down, side. So if we're going to flip the cup a total of 20 times, how many times do you think it will land face down? And how many times do you think it will land right side up? And how many times do you think it will land on its side? So your thought process may change depending on if you start it right side up or upside down, as well as the surface you're conducting your experiment on, because the harder the surface, maybe the cup bounces a little firm, maybe doesn't stick as well. So you got to kind of think about all the factors that go into this. So with your experiment, you've discussed the possibilities, you've made your predictions, so then you're going to take the time, flip the cup 20 times. After each flip, you're going to record your result in the table provided. So this is an example table. So on the left side, you have the attempt number. So attempt 1, attempt 2, attempt 3, 4, and 5. This is a smaller example. We're going to do it 20 times. Your table will have 20 options. So attempt 1, I wrote for the other column, the outcome, what actually happens. So attempt 1, it landed on its side. Attempt 2, once again, landed on side. 3, right side up. 4, side. 5, upside down. So I wrote what happened each time on the attempt. Finally, you're going to use your results to create a bar graph that represents the data. So there are only 3 outcomes we're looking for here. So you will have 3 bars. So on the horizontal axis, or the x-axis down here, you will be putting the result. So down here you will have upside down, right side up, side. And it doesn't have to be in that order, but those are the 3 outcomes. On the left side, the y-axis, the vertical axis, that is where you will write the frequency of each occurring. So let's say out of 20 times, 10 times I landed right side up. So right side up, that bar would go up to 10. Let's say the side landed 7 times. So then where you put the side bar, that would go up to 7. And let's say the other one was, so upside down would have been 3 in that case. So that bar would go to 3. So you're going to use this information to create a bar graph that will represent our data and let us know what our experimental probability would be. Once you are done using those numbers, you will create a chart that says what the fraction is, the outcome represented as a fraction of each potential outcome. So for instance, if our first one was 10 out of 20, you would write 10 over 20 as a fraction. Then you will continue by writing that as a decimal. 10 divided by 20 will give you the decimal, that is 0.5. And finally, as a percent, you take your decimal, multiply it by 100, and that gives you your percent. In that case, it would be 50%.